ఆపండి. మొదలవుతుంది. Shall we start?
సార్ 1 minute. ఈ లింక్ స్టూడెంట్స్ సార్, ఈ లింక్ స్టూడెంట్స్కి షేర్ చేశాను సార్. దే ఆర్ జాయినింగ్ సార్.
Okay. So another 2-3 minutes we'll wait then. The screen is visible there?
ఎస్ సార్, ఇట్ ఈస్ విజిబుల్ సార్.
Okay.
సార్ ఒక్క కొత్త లింక్ పంపించాను సార్, అది ఒకసారి షేర్ చేయండి సార్ స్టూడెంట్. యూట్యూబ్
పంపించారా మీరు?
యూట్యూబ్ ఒకటే సార్, యూట్యూబ్ ఒకటే ఇప్పుడే పంపించాను. అది వద్దు సార్, ఇంకా కొత్తది పెట్టండి.
మీరు పంపించింది చూశాను నేను. ఇట్స్ ఓకే, ఇట్స్ విజిబుల్.
ఇంకా అక్కర్లేదు సార్, సార్ కావాలని నేను షేర్ చేస్తాను.
ఓపెన్ చేయమంటారు దాన్ని? అవసరం లేదు కదా?
అలాగే అలాగే సార్, చెప్పండి సార్.
ఆ యూట్యూబ్ నేనే ఓపెన్ చేయాల్సిన అవసరం లేదు. చేస్తే మళ్ళీ కూడా 2 మిక్స్ అయిపోతాయి కదా.
అవును సార్, అక్కర్లేదు సార్, మీరు ఇలా కంటిన్యూ చేశాను సార్.
ఓకే ఓకే. Maybe Dr. Krishna Prasad can join and formally initiate the activity, I think.
Sir?
Maybe Dr. Krishna Prasad can join and make the formal in the meantime. Maybe let the people will join in the meantime. He can formally maybe initiate the session.
Okay, sir.
Or you can also initiate formally.
Okay, sir. అదే సార్, అదే సార్. మీరు గూగుల్ మీట్ సార్, గూగుల్ మీట్లో పాత నుంచి ఉంటుంది, పాత దాంట్లో జాయిన్ అవ్వండి.
Yeah. Good morning, sir.
Very good
Respected
morning.
resource person, Professor N.B. Venkateswarulu garu. My colleague, Dr. Chandrasekhar. With all his support only today we are able to run this program, sir. First of all, I thank Dr. N.B. Venkateswarulu garu for visiting JNTU Kakinada and delivering expert lecture based on this. After hearing your lecture, sir, last lecture almost 350 students utilized the last session. I created the Google form and shared that Google form to all first year students. After seeing their feedback, we started this session, sir. We initiated this session because I am technically poor in this context. I requested Dr. Chandrasekhar to help in this. Thank you, Dr. Chandrasekhar. My dear students, you are all requested to utilize this session efficiently. Morning session is from 10 to 12 p.m. Afternoon is 2 to 4. Even though I have mentioned like this, by seeing SARS convenience, you all are requested to utilize this session without hesitation, without wasting your time. Okay, it's a meticulous session. I know the resource persons are very well. I told during last meeting, he is my guru. I request you all to utilize, enhance your skills meticulously, note all inputs given by sir, because this is YouTube. Maybe it is available for some more time also if you want to review and refresh. Thank you, sir. Thank you. I wish you all the best.
Thank you, Dr. Krishna Prasad garu. Thank you a lot, Dr. Chandrasekhar, for for helping us for making this activity fruitful. So, shall I initiate the session, Dr. Chandrasekhar? The screen is everything is okay? Dr.
Yes, sir. Screen is okay, sir. It's please.
Okay, fine. Shall I will proceed at my own pace. Okay, thank you. I welcome all the students. Whatever may be the regions. Last time, there was some. Now, maybe not all the people are able to see the activity, the demonstrations what I made. So at least now today, things are going to be attractive, what I feel, because you are going to see the things in your hands. Maybe you might be sitting in front of a laptop or a computer, or maybe with your cell phone you may be sitting. Everything is in your hands. So now I hope today you will have better overview of this scratch. So in fact, maybe here also I wanted to emphasize this scratch language, though it is initially designed for helping for maybe developing the computational thinking in the youngsters, but I found that it is being used for the AI applications also. AI, so some of the programming environments, they are available based upon this. Some of the network simulators are based upon this same drag and drop concept. So normal programming languages, see what you might have gone through, they're all textual languages. You need to type, then you need to compile, then you need to correct the errors, then again you have to run compile. There is no compilation error, then you have to run. If there is some runtime error, Again, you have to correct your source code. So this is a different type of chain. Whereas this is a visual programming environment where the programs or instructions are just simply drag and drop to the code area. So there are some variants of this language. Snap, there is one programming language. Snap is also there, almost akin to, it is derived from the Scratch only. For the 3D visualization, you might have come across nowadays Industry 4.0, where the most important thing is 3D design of the object which you wanted to produce, print in the 3D fashion. So they are also implemented in this Scratch language, derived from this Scratch language. The concepts are same. Network simulators also developed using this one, network simulators, and AI engines are being developed using this Scratch. So that's where I thought I would introduce this language. No doubt, this is basically developed to inculcate coding thinking, algorithmic thinking, computational thinking among youngsters. In the sense, not youngsters means not you, kids, rather say 7 years, 8 years to 14 years kids. For their sake, this is developed. But otherwise, as I mentioned, lot of derivations from this. So many things are derived from this basis and used in the practice also. Okay, so you need to have scratch.mit.edu is a site. You can create login account. All your projects, whatever we develop, they can be maintained there itself. And also you can download an app. Scratch app is available. You can download to your desktop machine. You can install. Then offline also you can work. Not a problem. So here I'm trying to demonstrate everything in the online. So though there's no exception whether you do in the online or offline, doesn't matter. So now I have opened a new project. So maybe when I log in, so you will have an option to create. When you press the create, you will get a small, this is called as a editor. This is a Scratch editor. This portion, this right hand portion, maybe I say this right hand portion. So this portion, this right hand portion is called as this area is called as stage area. Stage, so maybe in the dramas etc., you will find a huge stage. In auditorium also, in our auditoriums also, there will be a stage where the actors will be performing their actions. So here the actors are called as sprites. So this is by default, there is one sprite called as cat. So we can have any number of sprites also. So by clicking this portion, we can select. So this maybe so I will just wanted to say so this portion, this downside portion is called as, if we click there, then you will get a lot of sprites. We can select, I will demonstrate that one. You can select backgrounds also. This button. And this area is called as code area, instruction area. And these are the instructions. And here the difference of buttons. So instructions related to the motion, related to looks, sound, maybe events, control. These are all. So I'm just trying to remove. So now. So just I wanted to press, if I press it, so we'll have a lot of sprites. We can select any sprite of our interest. Maybe I can select any sprite of our interest. So new sprite has come. New actor has come. New actor has come. Okay, so if you wanted to get rid of that actor, press. And this is the area, as I mentioned, this is the area. This area is a code area. So we can write the instructions. Here there is no type of writing means not typing here, just dragging and dropping. Dragging and dropping. Maybe dragging, instruction, writing a program is nothing but just dragging and dropping, no more than that. So now if I click it, so if I click this program area, this code is, now this is called as a code. This is the code. So just simply if I click it, action. So that actor, so this is the code for that actor. This is the code for that actor. So maybe again, this is the code for that actor. So now if I go on, so I'm clicking, the fellow is acting. So this is how for every sprite or actor, we can write the code of our interest. The code of our interest. Here, in fact, to be frank enough, so today I will be talking about, in computer science, one of the main important concept is in programming, iterative thinking, iterations, one after another, iterative thinking. That is one. So another one is, of course, we have recursive thinking, message passing. There is another important concept. Entire whole computer science systems are based upon this important concept, message passing. So I will be demonstrating these two concepts today, along with just giving a basic introduction of how to program. Then I will be talking about the what you call iterative thinking, and then what you call message passing. These are the two things I wanted to communicate. So Dr. Chandrasekhar, you do me a favor, maybe every half an hour or so, just say okay, such a way that is a feedback for me, things are moving fine. Is it okay, Dr. Chandrasekhar? Dr. Chandrasekhar, are you there?
Yes, sir, I am here, sir.
Yes, so just to give you for every half an hour or so, things are fine. Maybe just that feedback is required. Otherwise,
Definitely, sir.
I don't know. Yeah.
Definitely.
Thank you.
Thank you.
Thank you. Okay, so now let us assume that this portion, this is the, as I said, these are the instructions. We are not typing anything. So this is not a textual programming language. It is a visual programming language, and you are now basically, maybe I am assuming that you went to your childhood. So I'm taking you to your childhood because this language is meant for children's sake. Children's sake. So as I mentioned, to inculcate, to introduce the essence of programming from the school level itself, how to maybe be high-fi mathematics, high-fi things cannot be pushed into the school in one single go. So to make them at the same time, the importance of the computer science should be delivered to them. With that idea, the MIT Massachusetts Institute of Technology people, they have conceived this programming language somewhere in 2012 or so. So I'm fortunate to use that one. Though it is not meant for any publications, etc. It is meant my happiness sake. I started learning this one. Okay. In fact, I scribbled some books also. They are available in the Amazon. So I will be talking about first few, maybe an hour or so. I will be talking about how to use this one. How to use this one. So maybe let me
సెకండ్
get
సాటర్డే
rid of
కదండి,
this
సెకండ్
one.
సాటర్డే.
Wait, only this thing is okay. So now if I right click it, if you want it, I can duplicate the code, add it. So in fact, so you see, I'm just showing you this is a projection, protrusion, that is a maybe hole, it's more like that. So it will go onto the top, some buttons, some instructions have that style. So now this is another thing, it will go there also. So some they may not be having that freedom, which means that block will not fit here. It will not fit here. Some blocks. Okay, they will be knowing those things as time progresses. So now I want to get rid of this whole code, whole program. I want to get rid of it. So I can remove, delete block. So maybe I can delete blocks. Maybe delete block. Otherwise, if I want to remove all of them, so now in this empty area, this is a white area, then delete 2 blocks, whole thing will go. Yes, okay, whole thing will go. Okay, so maybe you, in fact, this fellow, I can move, I can change its here I can correct his orientation also. Here itself I can correct maybe 90 degrees. So by default this is his orientation, most of the sprites orientation. Okay, so just I wanted, let us assume that I wanted to position this fellow at one position, either through dragging I can position, or by instruction also. So I wanted, so let us assume that I can change these values. So I say minus 200, and maybe I wanted to say minus 150. So maybe if I execute it, so it will go there. It will go there. So there will be some limits also. Boundaries will be there. So maybe I wanted. So now let us assume that minus 100. So now if I execute it, so let us assume that just for the time being now, I wanted to make this fellow to move by 200 pixels, 200 units towards 90 degrees, whatever the current position, current orientation, whatever is the current orientation, then I wanted it should make a left turn 90 degrees. Okay, so I wanted, so let us assume that I wanted to move 200 degrees, 200 steps, and then make that turn 90 degrees, 90. Okay, so now if I click it, so now this portion only. So now currently where is it? It is where is the location? Minus 200, minus 100 is the location. Then when I click it, this code, maybe for that matter, when I click it, it has gone. Now when I click it, it has gone. When I click it, it has gone. When I click it, so now it made a rectangle, it made a square, it has moved in a square. So this square, I can even do the same thing. I can do even the same thing. Duplicate. Okay, now when I click it, very fastly it moves. It will come to that same original position. It will be moving. You are not able to see. It might have traveled, no doubt. So to feel, yes, it has moved. I wanted to make. So I will add something called delay. I will wait for something. delay. Okay, I will put maybe a delay. I will put a delay. I'll put a delay. So now, like this. Now when I click it, now you will feel. So it has moved. That's it. So the code has. So here, what we are having is, I'm asking to draw. I'm asking it to draw 4 steps, 4 sides. So I'm asking the sprite fellow to move along a square of size 200 by 200, 200 by 200 side width. That's our interest. So it is making the movement. Okay, but how did I achieve? How did I achieve? So repeating this code, this code, this code, this portion. This is the moving 200 steps, turning 90 degrees, waiting for 1 second. This is to wait. This wait is meant for our understanding sake. So if it has executed 4 times, then we are having the effect of making that one a motion of a square motion. So now this code is, instead of I have repeated. So I do not want to repeat it. That's what is the iterative thing, iterative solutions for loops, while loops, or anything, for loops, while loops, do while loops. So what for those things you will use in C language? I think you might have completed those concepts in your first year course. To execute some set of statements repeatedly some number of times. To execute some set of statements repeatedly some number of times. Is it fine? So now I wanted such a feature to be realized in this language. For that purpose, we have something called repeat. So now how many times I wanted to repeat to move this cat fellow in a square fashion? 4 times, because square has 4 sides. So now I am making. So now if I run it, so now we have such a movement. So maybe here some applications, like for example events. I wanted this should do something. Okay, if I click this button, if I click it, it should work in the same fashion. If I put that one, so you see the special nature of this one. I cannot put any code on the top of it. I can put the code on the below of it only. Below special, you can put there it's a special instruction. So there cannot be any code before this button, before this instruction. Only after that something. So whenever I click some event, see event is clicking this green button. It is making over. So if I click it again, you can see here this portion getting highlighted. The code, whatever I have written, that gets executed. Okay, now one more small thing I wanted to say. That is, you see this area called as a stage area. This is called as minimized area, minimized stage. Okay, currently. Now in a full swing, so now maybe if I click it, it's a full swing, full window. Now when I click it, okay, so I will show you something else also. So now I'll come back. Now I wanted something else to make the things attract. Now here you understood now this portion. So 4 times to run. If I run 4 times, so then this fellow will be making the what we call square motion. So what is repetition here? Making 200 degrees, 200 steps forward, and making 90 degrees rotation and waiting for a while. This is the repetition. These are the instructions to be repeated 4 times to get a to travel in a rectangle, in a square shape, along the square shape. Yes, there is some more thing we can do. Things make attractive. So here if you want to get rid of all these things, I will just push it. Then, so I wanted, here there are the extras, extensions. So I am pressing extension here. So I wanted to take an extension called pen extension, pen. So now I wanted, while this fellow is drawing, so I wanted some line also should appear to get a feel that as if it is working. So I wanted to set pen color, you can set, maybe any color you can select. You can adjust these things. Then you can select the color of your interest. Maybe you can select the color of your interest. Maybe you can select the color. So you can select the pen width also. Set pen size. Some size. Maybe I wanted to set the pen size as 5. And before this program starts, I wanted to arrange all the things whatever there on the screen. I wanted to arrange everything. And then okay, so now pen color, pen size, something else also. So I wanted to say pen down. You have to instruct the pen down, then only drawing will appear on the screen. Then after that, maybe, so now these are all things I just wanted put there. I'm just placing there. So the coding is here, nothing but drawing the visual blocks. So now first what I'm asking, go to show a location. So by anyway here its default position it is there. Erase all, something is already there, erase it. Set pen color, these are extras. Set pen size, then pen down. Maybe I wanted to do something, pen up also at the end I wanted to put such a way that next time when I run, it should not, okay, we'll see. If it is not there, what happens, we'll see. So now, if I now, for example, if I now click it, again, when I click this, it is erasing and doing. The things. So you have the feel of here, what is repetition, what are we repeating? So drawing one side, some instructions. What are the instructions? Making 200 steps and turning 90 degrees. These are the 2 instructions. We have repeated 4 times to get a feel of a rectangle. To make this sprite to move in a rectangular fashion. Okay, so now I just wanted, you see, maybe I just wanted some to make you. Okay, so I'm just again clicking full screen mode. Then I'm asking. It shows. No, just to make you, still you may be having some feelings. So I just wanted, now I wanted to share this one, share this project. So just maybe, I wanted you, instantly you can check it out. So maybe just something, copy link, I wanted to share. I can write some code here. So now copy link. So now some of you, so just you can try copy the link. So now some of you can try. You can you can just click. You can type in your thing. See whether that will be opened in your cell phone or not. If you are having mobile, so it is now an app. It is an app now. So you can just open in your cell phone. Okay, so no, you can try. Maybe later you can share your opinion. Okay, you can. This is one. It becomes a simplistic app. So many things you can do. Of course, many things you can do. Okay, so now you can try. I'm just giving you 1 minute. You can try. You can experiment on your cell phone. You can open this thing. I'm not putting because I don't have no option to share the link in the chat channel. So you have to type scratch.mit.edu/projects 500985730. Just simply when you click it, it can be opened from your cell. It becomes an app. Okay, I'm going back. So when I say create new, or maybe you wanted to see the inside of the present one itself, already project is there, you can. So now let us assume that, maybe I wanted to open a paint window. So maybe let me explain. So now you see, I just wanted to say rectangle, maybe rectangle. This angle, okay, this angle is 90 degrees. This angle is 90 degrees. And of course, the other side angle also, this is also 90 degrees. This is also 90 degrees. This portion is also 90 degrees. Both are 90 degrees. So now we are making rectangle or maybe square, just moving along this direction, then making 90 degrees right turn. Then moving along that, then making right turn. Again moving, then making right turn. Then again moving, then making right turn. I hope the paint window is visible. I am assuming paint window is visible.
Yes, sir, it is visible, sir.
Yeah, thank you. So, maybe if I wanted to draw a pentagon, how many sides? 5 sides. If I wanted to draw a, triangle. So what is the internal angle, external angle. So let us see. Now we will experiment. After all, small kids point of view I'm just making. So now I say 3, and instead of 90 I will say 60. Do we get rectangle 60? So now I'm clicking. Now, so it's not so your internal angle is 60, but what is the external angle? Is 120. So now if I make, now this is 120. So now I'm running it again. I'm clearing it. So I'm erase. Let us pen. So now pen, erase everything. Then I'll make this fellow. I'll position, erase all, and then I'll make that fellow just original position 90. Original position. Now let us assume we will run. So now run. Yes. So external angle is 120. So I wanted now, when I go to extend 120, how it has come? 120, 360 by 3 sides. So that is external angle. 360 by 4 sides, 90 degrees for a square. Maybe rectangle, of course. Maybe if I wanted pentagon, 360 by 5. So maybe, in fact, you can. So let us assume that I wanted to have 5 sides. So how much is a 360 by 5? So maybe 360 by 5, we don't know. For example, we wanted to keep it So you can write some instructions also, operators. I wanted 360 by 5. So 360 by 5. I can pull it here. I can place in that oval. So I can type here 360 by 5. 360 by 5. Now I click it. When I click it, that's it. So maybe I wanted, I will arrange everything. Maybe these directions I wanted to move, maybe to, let us assume that minus 150. Just now say I wanted 10 degrees. Decagon. So now I'm making by 10. Decagon. So now when I run it, so the screen is not sufficient.
Right.
Screen size is okay. So now I'm just erasing everything. Then size instead of 200, I'll make it as 100.
Okay.
Now when I click it, even still that's also crossing the boundaries. That's hexagon. So this way.
Actually,
Now instead of, let us assume that now here maybe I wanted. So this is the concept. So this is the concept. Repetition. So the concept of mathematical drawing, we can realize here. So what is repetition? Moving and making a turn. So depends upon the thing what you require, we can make. So let us assume that I will make this one, erase everything. So reduce, maybe for your sake, I will make as a 50. Now you may find happy. It is inside. That's it. So maybe you may be having doubt. You may be having what is the limits what you can use. For example, if when I click it, so you'll have different backgrounds here. We can create backgrounds of our interest. So just go down. There is something called here X, Y, Z. So these are the limits of this one. X value is minus 240 to plus 240. Y value is plus 180 to minus 1. So these are the limits of that one. So this is the grid available in this system. Okay. Maybe you can accordingly you can select also. Maybe I wanted to position, so the size etc. can be according to that. So different grids also. Maybe you can select maybe different maybe backgrounds of your interest. Different backgrounds of your interest you can create. You can create maybe art background. Anything you can change. So now let us assume that I wanted to add one more sprite. So this fellow, and I wanted if this program is the program currently for the what you call, this is meant for what you call cat sprite. And I wanted the same program, I wanted to use it for this. So I can pull, drop it there. So now when I click it, that program is available. So let us assume that I wanted this sprite. So now I wanted this sprite. It should make a pentagon, that should make a hexagon. Let us assume, just for the parallelly, both of them can work. And also I wanted to move this fellow to maybe minus 50 minus 100. So let us see now. So now I will arrange everything. Then I will click. Either this also I can click or that also I can click. So now maybe its size also I want it to reduce. If you want it, I can reduce the size. I want to make it as a 50% size. I can reduce the 50% size. Now parallelly, both of them working parallelly. Maybe it is not completed. So 360 by 5. So some problem with the, maybe it is hidden, I think. Okay. So, okay. So maybe the it is called a parallel programs. Some problem will come. So maybe I want to change this fellow's color. If it is running individually, it is working. So let us see again. So I wanted to change the color. I wanted to change this fellow color is different. I wanted to make this is a different color. So now put it back. Now come, I will arrange everything. Everything I will arrange. So now when I click it, let us see. So this is happening because there is a I will maybe immediately I cannot tag as a parallel. Both of them are working parallelly. There is a small delay. Okay, it will come. It will come after a while. Okay, you can add for more than one sprite. More than one sprite also. Okay, now let me take another example. I'm just trying to create a new. You can save. You can download to your computer, and as I said, you can install some software, and without internet also from on your computer you can experiment. So there you can work modify in the offline. Then you can upload to this online site. You can share to the people. Anything is possible. I'm just taking new application. New. So here I just emphasized loop. I wanted to say loop. So loop is meant for what? Loop is meant for what? To iterate, to execute some set of statements repeatedly. So mind it. So this language is developed for the sake of children. However, I am just making it. I'm introducing to you this one because I found that it is day by day. Its use in higher engineering applications also becoming more. So there are a lot of things derived from this language, and a lot of AI engines is being developed. Using this tool. So that is the reason why I am just feeling that you better have, by the time you come to third year, fourth year, maybe I feel that its use in engineering applications may increase. Okay, so now today this one I just wanted like loops. So maybe we have some loops control. So now forever loop, infinite loop. While in the brackets 1 if I put, then whatever code you write inside the while block is going to work infinitely. Going to make infinitely. So now I wanted this fellow to make go on walk. So forever. And whenever it hits the boundary, so instead of this one, maybe I wanted a ball. I wanted to take a ball. So let it be ball. And I will get rid of this one. So for this, I will pay forever. So I wanted the ball motion. Ball should move. Make a small movement. Okay, so whenever it hits boundary, it should bounce back. Let us assume that maybe I wanted to say move. So when I'm just clicking it, it move, it moves. Yeah, hangs there. So infinite loop. So it means that when it reaches the boundary, see, size, the x coordinate is not changing. The x coordinate is 247. That's all. That's the end of it. So I just won't want. So let it be. I'll put it here, and maybe I will first. What I will do is I will make a turn. I'll make a turn. Then move 10 some step, and then whenever it hits whenever if an edge okay, I wanted to bounce it. So now look here, this is a small code. When I click it, oh, that click I have to put it. So this button, if I put this button, so that's going on eternally. So forever. So it's equivalent to in your for loop. So in your for loop, so this instruction for maybe semicolon, maybe this code is also infinite loop. It works like infinite loop. Or while one, maybe this is also infinite loop. Maybe while 0 less than 1, maybe infinite loop. So this 0 will be less than 1 in maybe ever, it will be ever true condition. So whatever code written in the inside the while block, it is going to work in infinite times. The same manner here, this forever block, it works in this fashion. Forever. So let us assume that I wanted, I'm just trying to introduce iterative thinking. So something we want to go on, wait for something. For example, you see a shop fellow. So he will be waiting for what? A customer to come. When a customer comes, he will serve. Then again he will be waiting. One more customer comes, he will serve. Again he will be waiting. So in point, it will be going on waiting. In fact, these concepts are used in computer science also. For example, network traffic monitor. So it will be waiting. If a packet comes, it increments the packet counter. If that packet is identifies to be a sniffer, sniffer dogs, sniffer means its duty is to observe whether any harmful bits are there, virus is there. So what it does, it will just observe the bits. If it is so, it will stop that packet. Otherwise, it will allow the packet. So then you will be again waiting for the next packet to come. So how long it will run? Infinite times. So in fact, computer science, so there is a concept called Linux. Concept is Linux is whole based on what you call, there is one important concept as daemon, DAEMON, daemon. Okay, again there is a concept called device drivers. So device drivers are set of functions. Daemon is a program, ever running program. When you switch on the computer, so some of you, maybe if you have a Linux machine installed on your computer, so when you switch on, you will see so many messages, so much of messages. TTD daemon is started, so and so, telnet daemon is started, so FTP daemon is started, TCP/IP daemon is started. Daemons, they will be going on running on the computer, always infinite times. They will be continuously running. In fact, when it comes to Windows, they are called the services. Services. They are the ever-running programs. Ever-running programs. Maybe they run in the background, of course. So sometimes you wanted to run some code eternally. In the games also we use it. In the game development, this forever is very much required. So the wall will be moving eternally. So whenever I click it, so let us assume that I wanted. So let me write it small thing. When I click it, when I click this ball, so now some event. When I click that ball, so I wanted some score should be incremented. So for that, here also, you know, in our C language you have learned variables. So variables, when you declare a variable, what happens? Memory will be allocated. So when I declare a variable, memory will be allocated. So variables are meant what for them is variable? To store something. Okay, so here also we can have some variables. So I will declare a variable. Maybe I can create a variable, make a variable. So I can say some name, maybe clicks or hits, maybe something. Variable name only for this sprite only, or this only for this sprite only. For all sprites, if I have some more things, if they want, they also should access this one. I can give them permission. So now you are seeing this button. So maybe this can be on this window. You can put that one, or if I click it, it will disappear. If I click it, it appears. If I click it, it will disappear. So now I wanted the variables. Okay, so now a variable value, I wanted this variable initially hits to 0. And whenever user clicks this thing, I wanted it should make a counter to be incremented by 1. So now I am just making enable visible. So I will set this one at the beginning. Whenever I start this program, the hit counter will be 0. So whenever I click it, so there is an event. Whenever I click it, when this sprite is clicked, when this button, if I click it, I wanted this counter value to be incremented by 1. Counter value will be incremented by 1 variables. I wanted this counter will change the variable value hits counter to be incremented by 1. That's all, no more than that. It's just a simple change from the previous program and this program. A small game. So now I run it. So now when I click it, fast. This is fast. So when I click it, no use. When I click it, no use. I'm unable to catch. No. What is the problem? Oh yes. No. Oh, this fast movement. Oh my God. I'm unable to do. My score is 0. What the problem is here? The ball is moving. Impractical speed. Ball is impractical. No, not even. So I'll stop it here. So I will put a small delay. So now here, control, wait, I'll put a small delay. So now if I click this, delay value is very big value. So the weight is currently 1, very big really. So ball moves very slowly. Now I can click. My score is increasing. Oh, so much of score. So no practical. So previously the game there is no fun. We are unable to click. But now I want to make it a practical. So when I put the weight as 1, so there is no, I can score. This is also no charm. So I wanted to close, stop. So I will make this one as a small 0.5. Weighting is very small. Now I will run it. It is moving fastly. Even still, I can score so much. So which means 0.5 is also not good. So now we have these parameters has to be very good. Maybe 0.1. So now I click it. So relatively, life is coming. Life is coming. Life is coming. Life is coming. Okay, so now I'm just closing it. Maybe even this is 0. Instead of 0.1, 0.05. That may be little practical game. So now, okay. So now this is practical. And but see, this fellow is moving only horizontally because after so many 15 degrees. So I wanted to make is a random. We should not make such a type of thing. So I wanted to make small thing. So this value 15 degrees instead of 15, I want to put a random number. So now go to operators. Go to pick a random number between not this one. Random number. So now that many degrees I wanted to move. So maybe between 1 to 180. Some degrees. Now if I see that problem will never come. So these are all practical game development. So now I'm clicking. I hope I'm able to use, I'm giving meaning for your time. So that way, in some applications, forever loop. So repeat loop, forever loop. So we have a lot of other things. Iterative thinking, doing things repeatedly, iterative thinking. Maybe I have explained today how now we have declared a variable. How to declare variables. Let me. I will close this one. So this is called this small area. This is called as all my projects, all my things. So maybe I wanted to save this one. Save now. Now I wanted to go to my projects just to see what are all things available. A lot of things are there. So one game I just wanted to show you. Craps game. See inside. Okay, so there is something called basically here it's used while loop only used. Okay, so maybe when we are children, we might have played this game. What is that game is? So you write something in your hand. You will not show to your friend. You will ask him to guess what did you write in your hand. But you will give a hint only. Hints. So you say at the first, the number what I have written is in my hand is its value will be anything between 0 to 200. This is a hint. And your friend has to guess it. So you may give 10 chances. That also possible. Okay. So let us assume that in fact you have written a number in your hand 177. You will not inform him. And your friend has to guess. Now let us assume that your friend has to, he says that it is 100. His guess is 100. Then what you do is you will give a feedback. As your guess is low. So as you already mentioned that the value will be 0 to 200. And when your friend has given the guessed as 100, you are giving a feedback to him as 100 low, which means that value. If you wanted to play, your friend has to play intelligently. So then his guess has to be next time should be between 100 to 200. So he has to guess, next guess should be between 100 to 200. So in fact, this is in fact computer science. This is called as a binary search. Binary search. So already you said 100 itself, you are giving a feedback as low. His guess is low. Means the value what you are written in your hand is not that. It is more than that. It's not less than that. So your friend has to play intelligently. So he will be playing intelligently like this. Oh, for 100, he's giving me feedback as low. And I know that 200 is the highest value. So to play intelligently, average of it. So in fact, this craps game, it is available in Linux systems from 1970s onwards. It's just play text game also, but now we can make it a visual game. Okay, so he will assume next time he will say 150. Then you will say low. Your guess is low. For 150, low. 200 is the highest. Now this time your friend says 190. What is written? 177 is the one is written in your hand. So for 150, we have given a feedback as low. Then as the user has entered 190, your friend, now you will give a high. So 150 low, 190 high. So which means that he will, if he wants to play intelligently, there is a repetitions. The game is played repeatedly. So this is the one simulated here. So I just wanted to show that one. So click it. What is your guess? So now let us, I don't know, random number. It selects a random number, I don't know. So benefit of random numbers is, even if the program is written by me, I don't know what is the value it's going to take. So maybe if I play, also I do not know. If my child plays, also she will also not be knowing. So I cannot do any mischief. Game will be game only. Game will not be just management. So let us say I said 100. 100 I have entered. Sorry, your guess is high. What is your guess again? So we know that lowest is 0. For 100 it's giving me answer is high. So which means the value would be somewhere between 0 to 100. So I say 50. I am playing intelligently. Sorry, your guess is low. So 50 low, 100 high. So now I enter now 75. Your guess is high, which means that 50, 75. So I will enter 65. Your guess is high, which means that is 50 to 65. So I will enter 67. Oh, sorry, 57. I'm playing intelligently. 50 low, 57 high. So which means that I will say 54. Your guess is low. So now 55. 56 then. Wow, you won. Wow, you won. So, in fact, so this is how that piece of code, it runs infinite time. It gives me repeat loop. I have used it 10 chances. It gives. If I don't guess within 10 chances, you will get a message saying that I'll ask again. I will do. Just I will enter. I will enter sequence numbers 1. Without worrying. I want to show that after 10 chances, it gives me message saying, sorry, your guess is low, I'm giving just to give you a feel. Sorry, your guess is low, 10 chances. Sorry, you lost all of your chances. Okay, so that is also 10 chances it gives me. See here, 10. Now one small thing I want to make this one little more attractive. I wanted to add sound also. Text to speech. Maybe I'm trying to edit. So what I do is I will copy, save as a copy. I'll edit that one. I'm copying. So I will making craps one game, craps one. I'm just changing the name, craps one. Now I will add something called text to speech. So I will put some things, directions. So now, so I will do speak. I say speak. Okay. So now I'll copy that one. Copy. So here I will copy. I'm copying. Then so I say speak. I'll copy again that portion. I'll copy that portion. Okay, wow, you won. Wow, you won. Maybe I will just to make these things attraction. So maybe speak. So sorry, I'm typing. You can copy also. Your guess is low. Your guess is low. Try again. Try again. Maybe I'll speak again. So sorry. Your guess is high. I'm adding sound interface. Guess is high. Try again. I'm putting sound also. And even at the end also I wanted to put. So maybe speak. Sorry. Some message I'm putting. Your 10 chances are over. Chances are over. Next time better luck. Next time better luck. I'm just adding sound, text to speech. So I'm typing text and that will be spoken. So now let me show you. So now I'm just planning. Okay, maybe I say 200.
What's your guess 1 to 200?
Sound is coming.
Your guess is high. Try again.
Your guess is high. So now maybe I say 120.
What's your guess 1 to 200? Sorry. Your guess is high. Try again.
Your guess is high. Try again. The sound is also coming along the text message. So now 100.
What's your guess 1 to 200? Sorry. Your guess is high. Try again.
So like this. So you can make this app little more attractive by adding sound also. So these are all extra extensions. Even camera also we can add. Even you can add camera also. Okay, so now stop. I'm stopping. So incidentally, now I wanted to show some more concepts, new. Creating a new project. So lot of things we can show, lot of things I can show. So now maybe events. So this below, in fact here, so this is currently this button. This is the active one. This is the active one. This is the active one. And this is the costumes. So when I click it, so this cat fellow, it has two costumes, means two type. It's figures, two figures it has. Maybe if I'll select one more thing. So this fellow, bear fellow. So now I will go to costumes. So for that we have different. See, when I say this is the one shape, and you see the leg is changed. First leg up. Maybe first leg forward. See the small changes. So It has many costumes. So same figure, but a different changes. So to animate, to create the animation effect, costumes are used. Maybe we can modify, we can arrange, we can do many things with these costumes. Maybe I don't know whether it cannot be taught immediately, but I wanted to explain you how to use those costumes. So just now I'm just going. This is the costumes. I can make a sound also. So sounds also. We can record sounds also. For example, if I play, I'm playing play. We can record also. But let me use first costumes. So two costumes are there. So I wanted to generate a feel of as if this cat is walking. So I just wanted to the code area, then control. Then I say repeat 10. So instead of 10, I'll put 20. Let this fellow, I will drag this fellow here. Then looks, when I go looks, so I will change the costume. Next costume. There's only one, no more than that. Next costume. I'm putting a loop here. What is loop? It is just changing costumes. So that is such a way that you will get a feel of as if it is walking. So now I'm just, if I run it, it will be working as if it is running there itself. Look here. So maybe again, if I wanted to have real thing, then what I will do is I'll put a weight also. I'll put a small weight. So maybe 0.1. Now I'll make, oh, it is moving. But really it is not moving. It is at the same point. So I wanted real movement also. So then go to motions, add. Now when I play it, so as if it is walking. The same thing is possible. So I will add this fellow. And the code, I will put that code. I will copy that code for this fellow also, same code. So now I'll move that fellow to somewhere, and I'll move that fellow. I'll reduce this fellow size by 50%. So move it. So now when I click it, oh, you get a feel of whatever feel, the movement feeling. Maybe let us assume that we wanted maybe bat. I wanted to reduce its size to 70% size. Maybe you wanted to reduce to 70%. So 70%. I'll put it there. Then I'll copy the code for this fellow. Same code I wanted. So now maybe when I click it, this fellow will be, that fellow will be moving. So now currently I wanted to start copy. I'll copy. So now bat. So now it is available. Maybe previously it has copied. Now when I click it, bat will be, see, bat will be moving. I wanted all of them should make movements. So then what we should do is we put button for all of them. When I click that green flag, all of them will work. So now here, So now, just now we understood what we understood is we made just to have a feel of illusion. So animation feeling. We have to repeat the costumes. So I don't know whether you have seen in your village touring talkies, they'll cameras or they'll have a film. So if you see a series of same image with small change in that, if that is played at a particular speed, frames per second, some FPS, so then only you'll have a real dynamic feeling on the screen. So the same manner here also, our costumes here, if I see the costumes here, so the costumes of this one, very small change between this and that. So we are displaying the first one costume after another costume to get a feel of that, as if that fellow is moving, as if that fellow is moving, as if that fellow is moving. Okay, so this is the code to have movement. So, but here again we are using, we introduced to the children. So here we wanted to teach the children. So the objective of the MIT people bringing this language is to make them to understand when they have to use repeat loop, some other loop. Okay, so loops are used to do some calculations repeatedly. Loops are used to do some calculations repeatedly. So let us assume that, okay, so I'm trying to maybe I'm saving, save now. So previous example I will take. So okay, otherwise we'll create another new one, not a problem. Create a ball, creating a new ball. So I will get rid of, so I will have a one ball, and I will remove this one. So let us assume I will take one more thing, a bowl. So in fact, so if the bowl, if it touches the ball, I wanted some counter to be incremented. So let us assume that not necessarily one ball. Okay, the ball, what it has to do is eternally it should fall down. It should come down vertically from the top to bottom. Slowly. Whenever it touches the bottom means minus, y coordinate is minus 180. So if it's the bottom, then again it should go to some random position on the top position. So I wanted such a way that forever it should do like this. So what is it should do forever? So I wanted event forever. Ball should, okay, ball behavior we wanted to control. It should come down. Means y coordinate should come down. Y coordinate should come down. So y coordinate should reduce. Change y coordinates. Change y coordinate. Why? Because you see, reduce minus 10. So before that, minus 10. It should reduce slowly. Slowly means some weight. We'll put some weight also. Weight 0. 0. At the starting, from where it should fall, from some location, from the top location, from the top to bottom it should fall down. Whenever it touches bottom, it should go to some other place, then it should fall down. That some other place randomly. So I wanted some random location. So now what I want is random motion. Go to set. So I want to set something. So go to something, some random location. X coordinate should be random, y coordinate should be 180, for example. Or from the top it should come down. So but x coordinate should be random. X coordinate should be random. So I wanted random. So now operators, put a random number, between so 1 to some number. So maybe I can put a random number -242 plus 240. X coordinate, we know that it is changes from -242 to. So x will be random, y is 180. So now it should come down step by step. Then whenever it reaches, whenever xy coordinate becomes -170, more maybe less than -170, I wanted it again should go to another random position. This is the behavior I wanted, for example. Now what I will do is if condition, control, if some condition, if y coordinate. So I wanted to compare y coordinate. So operators, y coordinate, y is less than y coordinate. So I wanted y coordinate is less than -170, -170. Which coordinate? Y coordinate. So now y position. Then I wanted this fellow, I want to duplicate. Okay. I'll put it here. So total will check up. We'll check everything. So now that's it. So now when I click, I'll put a control. Even when I click it, oh, this whole code is okay. I did a mistake. So for that ball I have to do. So I'll put up for that ball. The ball. Okay. I will remove this code for that. So for the ball. So now when I click it, you see now let us see ball how it moves. Ball is falling down. So somewhere it is coming. You see, infinite times it is maybe running infinite times. Maybe I wanted to duplicate it. I can duplicate. I can create a duplicate of it, or maybe I can create another ball. I can take another ball. There may be variety of balls. Maybe I can take a ball. Okay, so then I will copy that code for this ball also. Copy that code for this ball. Now when I click it, so both of them. So here the loop. So ball should go on. To bring the practical life to the programming, children. That's what I'm saying. Iterative thinking. So unfortunately, while maybe learning C language, maybe sometimes to get a feel of loop, the examples what we teach sometimes maybe mathematical. So some people they will easily catch, some people may not catch. So or especially I believe this orientation, so a practical visual orientation before teaching the C language aspects, mathematical concepts, etc., they makes them a little more comfortable in the class. That's my belief. So now to bring the practical life, so let us assume that this now the life I want to make a game. So I wanted to, when this bowl, if the ball I can move, let us assume that bowl I wanted to move, and whenever I place the ball comes onto the bowl, I got a score. If that should be the score I want. That's fine. So I want to increase the score. Okay. But I don't want. Now I wanted to make ball to move. This fellow I wanted to move. One approach is I can move with hand. So I can move like this. So let me see. Let me hear now. Now, am I moving? Am I able to move? No. No. So even after click it also. No. 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 This is not giving. Which means that yet the code is not written for that bowl. We have not written the code for bowl. Okay, nothing has been written. There's no code here. So now I wanted to write some code such a way that I can move. I wanted to move such a way using left arrow, right arrows. Left only. I wanted to move left arrow, right arrow. No more than that. So when I click the thing, it should come. It's first its y coordinate. I wanted to position this y coordinate of that bowl. Y coordinate of the bowl. Y coordinate of the bowl. Set y. Set y. So set y coordinate to some maybe 1 minus 1 minus 1 or maybe 130 something. So downside bowl should come at the beginning. And I should be in a position to move if I click now here events. I am writing the code for the bowl. I am writing the code for the bowl. See here, you don't have the same thing. If you wanted to if you have to introduce high level languages, it's a load of efforts, load of things you have to teach. Then only they will understand. So much of things. Whereas here, this visual programming makes the life easy. So it can be taught for a small kid very nice. So now I wanted when left arrow, right arrow pressed, when right arrow pressed, I wanted mouse x coordinate should be incremented by 10. X coordinate should be incremented by 10. Change x by 10. Then maybe when I write here, when I press, I'm writing the code for when left arrow is pressed, x coordinate should be changed by minus 10. So such a way that I can move what I call as if that can be moved minus 10. That's it. Now look here. Now we are going to make a small thing. Now I'm pressing the right arrow. The left arrow, the ball is moving. So yeah. So now I can move. But if I cannot move the mouse. Through mouse I cannot move. I cannot up arrow, down arrow also I cannot move because I have not written code for them. Okay. So I wanted like that. Bowl is moving. Balls are moving. They are eternally they are moving. Balls forever is used to make balls to move eternally. So now we wanted to bring it little more life. What is that life is? Whenever this fellow touches, so even the code is can be written. Here I can write the code. There also I can write. So score I wanted to increment. So first we'll take a variable. Score. Make a variable. Score for all sprites. Score. So initially set the score to 0. Set the score variable to 0. Score to 0. So whenever this fellow touches some object. So now events. So when here there is a when touches, when I receive stuff. So when I sprite clicked, when I receive, when there is something called so some text to speech, pen, music. Okay. So events. So sensing. So touching. Okay, if touching mouse pointer, so okay, if touching mouse pointer or if touching mouse pointer, so otherwise touching mouse pointer, color touching something, this color touching something. So those are all options. Those are all options. Okay, so that is also possible. Otherwise, so when the sprite is clicked, when backdraw switches to back, okay, when loudness, when message one, so maybe we will use touches. There is something called distance also one can use. So distance also we can use. So distance to the ball. So if the distance is less than something, less than, when I place near to that ball, it should increment. It should increment the score value. So let us try. So now what I do is, here also I'll put forever. So what I will do, forever, will control forever. And I'll put some control if condition. So maybe if the distance is less than distance sensing operators, if the distance is less than, maybe I'll change this one to something 10. I'll put here. So now stop. So then increment the counter by one operators variables. Change my variable value, score variable by 1. Let us see. So now I'll put it there. So now when I click now the whole thing. So when I click it, when yes it is near. So that parameter. Oh, okay. So now I'll stop this distance instead of greater than, I'll put a less than. So I'll put a less than. So I'll put less than. So sense operators less than. So maybe 10. Now when I run it, so now if I move, okay, if I move near, you see, the counter has increased. Now again, counter has increased. Now again, counter is increased. So now, the counters have changed. If something happens to this, nothing will happen. Because I did not write the code for that. So now maybe why so many times it is increasing? Because I did not put a delay here. I can put a delay here. Wait for a while, etc. You can put. Okay. So here my interest is to let you feel that iterations to do something repeatedly. So maybe let me explain some other things. I will save this one. Save. So maybe some other games. So many things. Maybe I used to teach. So otherwise I will log out some other account, I will say. So now some more games. So now just to show you. So then let us see. So nothing has come. Okay, let me go through. Okay, small example. Maybe see inside. So I want to find out the both minimum and maximum of two numbers. Minimum and maximum of two numbers. Okay, so normally how many comparisons are required? How many comparisons are required? So I am clicking it, just showing, it will ask you. So,
Enter an integer.
so maybe I entered 10,
Enter another integer.
maybe 90,
Enter an integer.
maybe 78,
Enter another integer.
maybe 5.
Maximum equals 90.
How that is, how it has done is,
Minimum equals 5.
how it has done is, maximum of this AB, minimum of AB. One comparison you can do. Maximum of CD, minimum of CD. One more comparison. Then maximum of AB and maximum of the CD. Maximum of those two things. Maximum one comparison. Minimum of this CD and minimum of AB. One more. So with 4 comparisons we can do this one. I wanted to show something else. So to have a feel of C programming. Load more. So student highest marks. Okay, one more thing, some more things. Lot maximum of 3 numbers. Average of whose marks is more. So now let us assume that C this one. Let me ask you, you might have already completed C programming. You might have completed C programming already, or maybe you might have reached loops and also arrays you might have used. Array. So now question is, what is meant by an array is not the question I wanted to make. Why do we require an array? Why do we require an array? No doubt array is meant for to store similar values, similar elements, no doubt. They occupy the consecutive memory locations. What is an array? I am not asking. Why do we require an array? No doubt to store something. What for is the storing if we don't want to use them? So that's the most important thing. To store something and use it as many number of times as you wanted. As many number of times you wanted. For example, I wanted to calculate the average of n students' marks. Whose marks? Who are passed? Or whose marks are more than class average. Okay. So first maybe if I don't use an array, so you have to read what is your marks, what is your marks, what is your marks. So after reading all the students' marks, we will have total. So with one loop we require. Then again, we will find out average. Then again, what is your marks? Again you have to ask to compare with the average of the class. If it is more than the average, you have to sum up. So for that, second while loop is required. Second loop is required. Second time data you have to read it. Same data, maybe if there are trillion students are there, second time again you have to enter. But if you have an array, so the same thing is here, it is called as a list. List, you can have lists. So they can be used, same thing can be used any number of times. Arrays are used for storing the data, no doubt, related data, and use it as as many number of times as you want. So now that's what I'm going to show in this example. So here I'm using a list. I have created a list, and I'm trying to show run. Okay, I'll click it.
Enter number of students.
So enter some number of students. I will enter 5.
Enter students marks.
So when I enter 90,
Enter students marks.
90, 91.
Enter students marks.
One by one it is reading. 31, 32.
Enter students marks.
Another student marks 34,
Enter students marks.
50, 66.
Enter students marks.
So how many? Maybe again entering.
Enter students marks.
Maybe
Enter
I
students
don't know
marks.
how many I have given. I'll stop here. Okay, maybe it has gone to infinite loop or what. So repeat n. So enter n to answer. So I will clear everything. Okay, I'll put events. So now I click.
Enter number of students.
Here n is not visible, just to show you. Maybe if n is required to be visible, you know, already I have mentioned n. I'm making n. Okay, so now I'm just running.
Enter number of students.
Now I enter 5.
Enter students marks.
So maybe 90,
Enter students marks.
maybe 89,
Enter students marks.
56.
Enter students marks.
So like
Enter
that.
students marks. Enter students marks.
So it went to some infinite loop problem. I think maybe I'm sorry. I will just close it. I will create one more thing, not a problem. I will create maybe something wrong with it. Somewhere I might have modified this one. I will create new one. So I will create a list. We can create a list. So make a list. So maybe for that you can give a name, marks. So there is an empty list. So I wanted to read one by one and add it to the list. So I wanted to ask maybe one more variable, n, number of students. Okay. I wanted to read a value for it. So I want to read a value for it. So whenever a user asks, there is something called input. So there is a sensing module. So you want to ask, enter a number. So when I say so enter number of students. So a prompt will come. Already you have seen that prompt. When I click it, see that prompt will come. Text input. So whatever I enter, that will be stored in this variable answer. Now for that one I wanted to assign to n, the variable n, for example. So I wanted to assign, so set my variable n to that answer, sensing to that answer. This is the code you have to write for interactive input. So if I wanted, I will show variables. I place n, it is there n, it is being masked with this. So I am just, so it is, n is there. So now n is here. Okay. So now when I click it, if I enter 9, so that 9 is assigned. So how did I do? Set n to that answer. So let us assume that I wanted a loop. One by one it should ask some numbers. Whatever user enters, that they should be added to the list. Let us assume. Now I wanted a loop is required now. How many times the loop has to run? So whatever number of students are, that many times. So all the students' marks I have to read. I have to read. So now control, repeat. How many times? Not 10 times, n times. So n times I wanted to put n times. So what it has to do n times? It has to ask something and add. So it has to ask. So ask. Enter a student marks. Enter a student mark. Enter a student mark or another student mark. Another student mark. Whatever user enters, that is available in the answer. That has to be added to the list. So now I'm trying to do variables. So add thing to marks. Add thing to marks. What thing? Answer. So let us now we'll run this program just simply. We'll run this program. So now when I click it initially, so now this previous value is 9. Now I will ask you. Enter number of students. So I have not added sound. If I would have kept sound, the sound also will come. So now maybe I entered 5. You see here, 5 has come. Now I enter another student marks. So now I entered 90.
Explain me, sir.
Yes, please. Yes.
Sir, the time is around, we have only 10 minutes, sir. Just to remind
Okay.
you, sir. Just to...
Fine. So I'll stop with this example.
Okay, thank you, sir.
So this 90. Maybe next student and another student marks 78. It will be added to the list. Maybe another student marks. It is asking 67. So I'm going to add to the list. So list means an array. So see here, all these things are introduced to make the student, small kids, to understand the compute programming aspects. So now I introduced you to the iteration. So now here loops are used. Now in this also loops we are using. At the same time, array. So array here is called as a list. So why do you require an array? Same data. If I require to use more than once, you require an array. So same thing here. I'm just trying to take this example because you are already exposed to C language. Such a type of example makes you interested. That is the reason why I'm taking. Otherwise, lot of game development, lot of things you have to store. Why you may require to store the previous location of the mouse, previous when he hits, where did he hit? This type of information you require maybe at a later stage in the game development, game running. So all these things are required to be stored in the arrays, lists. So lists are to store something, such a the intention of using that one in future as many number of times as you wanted, not to store only for using only once. You require that same thing again and again. So you require an array. So the same here is called as a list. So now I enter 78, maybe 56. The total. So the array is there. But I wanted this can be reused. It can be reused. Okay. So as let me maybe I'm sure the concepts. I think I'm not fast. I think probably incidentally. So I don't have feed to me from you. So probably maybe you can send maybe to me your views. Maybe in the evening session we can do something different. So or rather maybe to make your expectations. Otherwise. Yes, I require some input such a way that in the evening session I can make things a little more attractive. Otherwise, today morning session I have given you a live demonstration of what is a loop, iterative thinking. So to introduce to the children, this has been brought up, and this language is a visual programming language. You can simply drag and drop. And as I mentioned, this language and its derivatives are used for the hi-fi AI systems development also. That is one of the reason why I wanted to make you to use this tool. Okay, not because maybe, okay, that is my interest. Okay, so I wanted you to send your anything Venkat, which I think you may be already knowing my email ID. Some of your friends already sent me email, so you can send me your views such a way that evening session maybe I can use your input. So thank you, Dr. Chandrasekhar garu.
Thank you, sir. Thank you very much, sir.
So I think is it new for them or not?
Yeah, it is a completely new thing, sir. Scratch.
Yes. So in fact, that's what. In fact, it is used for the machine learning algorithms design and development. For that purpose, also they are using network simulators. Also, they are developing using its derivatives are all many are available.
Yes, sir. Actually, I have registered for one course in the NPTEL, sir. With Python.
Okay.
In that one
Yeah.
session has been done with the Scratch only, sir.
Oh, that's fine.
Yeah.
That's fine. Yes. From this too, you can again convert the code, whatever you have written here, it can be ported to Python also.
Okay, sir. Okay.
And whatever you write in the Python, you can port from to this also. There are also convertible, reversible things are possible.
Okay, sir.
Okay, thank you. So,
Thank you very much, sir.
thanks a lot. Thank you, Dr. Krishna Prasad Garu. So, we'll meet at 2 o'clock sharp.
Sure, sir. Sure. Thank you.
So, those two links, I think you have forwarded to them.
Yeah, I have forwarded to Krishna Prasad, sir, and he has forwarded, sir.
Okay, thank you. Thank you.
Thank you very much.
Thank you.